For decades, Uranus was believed to have just 28 moons until James Webb shattered that certainty. In 2025, its piercing infrared sensors spotted something Voyager 2 and Hubble missed entirely. A moon so faint and tiny, it's dwarfed by most cities, quietly circling amid Uranus's ghostly rings. This unexpected discovery not only rewrites the planet's census, it raises a bigger question. If new worlds can slip through the cracks right in our own solar system, what other secrets are still hiding in plain sight? The unanswered mystery of Uranus is about to deepen. At the edge of our solar system, Uranus stands apart from its planetary siblings. Its axis is tilted nearly 98 degrees, causing the planet to spin on its side as it orbits the Sun. This extreme tilt transforms seasons into decades-long cycles, with one pole facing the Sun for years before plunging into darkness. Encircling the pale blue globe, a set of narrow, dark rings barely reflect sunlight, rendering them almost invisible except in the faintest glimmer. Unlike Saturn's bright bands, these rings seem to absorb more light than they scatter, shrouding Uranus in a kind of cosmic dusk. The planet's atmosphere, rich in methane, deepens the mystery by masking surface features and swallowing much of the incoming light. Such peculiarities have made Uranus a puzzle for astronomers, hinting at hidden processes and unseen worlds within its shadowed domain. On January 24, 1986, Voyager 2 swept past Uranus, becoming the first and only spacecraft to visit the ice giant up close. Its brief encounter lasted just a few hours, but the data it returned transformed our understanding of the planet's neighborhood. Voyager's cameras revealed 10 previously unknown moons, bringing the total count to 15 at the time, and expanding the known family to include small, irregularly shaped satellites orbiting close to the rings. Each new find drew its name from Shakespeare or Pope, following a tradition that set Uranus apart from the mythologies of other planets. By the end of the 20th century, ground-based and space telescopes had pushed the census to 28. Yet a fundamental limit remained. Voyager's instruments, advanced for their era, could not detect objects smaller than about 20 kilometers across, especially amid the glare of Uranus's rings. Between the gaps in detection and the fleeting nature of a flyby, astronomers were left with a tantalizing question. How many more worlds might be hiding in the planet's shadow, just out of reach of the technology of the day? Infrared light reveals what visible eyes cannot. The James Webb Space Telescope operates in a wavelength range from 0.6 to 5 microns, far beyond the capabilities of Voyager 2 or Hubble. Its segmented mirror, stretching 6.5 meters across, collects faint traces of heat and scattered sunlight that slip through the darkness around Uranus. In this part of the spectrum, the icy rings and hidden moons no longer vanish into the planet's glare. Instead, NARCam, the near-infrared camera, captures subtle glints and shadows, mapping the system with a clarity never achieved before. Every photon gathered in these long exposures carries information lost to older telescopes. The difference is dramatic. Where Voyager's cameras saw only the brightest moons, Webb's infrared vision picks up objects hundreds of times fainter, teasing out secrets from the cold, distant reaches of the Uranian system. This technology opens a new window, making the invisible visible and setting the stage for discoveries that once seemed impossible. 10 exposures, each 40 minutes long, were scheduled to track Uranus in the faint infrared. The observing run began quietly, with NIRCam's detectors registering the planet's glow and the sharp lines of its rings. In the early frames, nothing unusual appeared, just the expected pattern of moons and scattered light. But as the sequence progressed, a subtle anomaly crept across the images. A pinpoint, barely brighter than the background, shifting position from one frame to the next. Most would have dismissed it as noise or a cosmic ray hit. Dr. Mariamiel Mutamid, leading the analysis at Southwest Research Institute, noticed the speck's steady movement. She checked the timestamps overlaying the 10 frames. The faint dot traced a smooth arc, matching what orbital motion would look like if a hidden object circled Uranus. For hours, she replayed the sequence, testing every possibility. Artifact, background star, processing error. Each time the signal persisted. The evidence pointed to something real, something that had eluded astronomers for decades, now captured in a handful of faint, moving pixels. Within Uranus's crowded inner system, the line between moon and ring blurs into a shifting boundary. S/2025 U1 now joins this intricate dance, orbiting just beyond the main rings between Ophelia and Bianca. Its presence hints at subtle gravitational effects, nudging, stirring, perhaps even shepherding stray particles along invisible paths. Each small moon in this region shapes the architecture around it, influencing the rings not with brute force but through countless gentle tugs that accumulate over time. The discovery of such a faint, fast-moving object raises a deeper question. How many more hidden worlds might be weaving through the shadows, quietly sculpting the chaos we see from afar? Somewhere beyond the reach of even Webb's current vision, other small worlds may be weaving through Uranus's shadows. The discovery of S/2025 U1 hints at a hidden population, tiny moons too faint or too close to the rings to reveal themselves just yet. Each new detection rewrites what seemed settled, suggesting that the true census of Uranus's satellites remains incomplete. The search now opens to all possibilities. What other secrets are waiting in the planet's dim outskirts? If you could choose, what name would you give this newfound companion? Shakespeare or Pope? Where should the next chapter begin? In February 2025, the James Webb Space Telescope detected a moon just 8 to 10 kilometers wide, S/2025 U1, hidden among Uranus's rings. Voyager 2's 1986 flyby and decades of Hubble observations missed it entirely, showing how far technology has advanced. This faint, fast-orbiting body brings Uranus's moon count to 29 and reveals that our census of the solar system remains incomplete. S/2025. U1's nearly circular orbit and proximity to Uranus's ring suggest it may help sculpt the planet's intricate inner system, but its precise role and origin remain open questions. The discovery underscores that even close to home, there are still objects waiting to be found. As Webb continues to scan the outer planets, scientists now have new evidence that more hidden moons may be shaping the dynamics of Uranus's rings. For now, S/2025 U1 stands as proof that exploration, powered by new tools and persistence, continues to rewrite our understanding of the solar system.